For task 4, we have write an expression, algebraic expression for each model. So this is 1, 2, 3, 4. This would be 4 minus 1. And if we were to combine it, we would get 3, because these would cancel each other out. This would be 1x plus 1, because there's one single one here, and this would be a value of x. Here we have 1, 2, 3 x's, so x plus x plus x, which gives us 3x. One, two, again, 3 x's, so x plus x plus x plus 1 minus 1 minus 1. All right, let's figure this out. We have 3 x's here. Those go together. And then 1 minus 1, that's nothing. Minus 1 gives us, we're left off with negative 1. We can see that because these ones will cancel each other out. This big guy, that's an x squared. So we have 1x squared. So you can write the 1 in front, or you don't need to. You can just write it like this, or you can write it with a 1 in front like this. So either one means the same thing, but here we have x squared plus one single one. In this one, we have an x squared and an x squared, so it's going to be x squared plus x squared, which gives us 2x squares. Because those can go together, they are like terms. Now, press pause and create your own expression and then solve it. Lastly, here we have some to evaluate. So we've seen this before. Was my analogy of when you go to like Walmart and you're playing that game where you have the crane and it grabs the toy and then puts it into its place. Hopefully you win, but you spend so much money on it. That's exactly this. You're going to take the 6 and input it where the x goes. Right, we take 6, input it where the x goes. And what operation is happening right here? Do we see any pluses or minuses or division between the 2 and the 6? Nope, that means it's multiplication. So we get 12 plus 5, which we can put these together to give us 17. We're going to do the same thing here. So the negative 5 gets inputted where x is. So we have 14 minus 7. And then this is multiplication. So the negative 5 will be multiplied by the negative 7. And following BEDMAS, we have to do this first. Negative 7 times 5 with a negative. That's going to give us a positive result of 35, which leaves us with a 9 and a 4, 49. All right, only a few more here. Here we have 21 minus 2, and then the 7 is going to be inputted right beside the 2. Again, multiplication comes first before subtraction, so we're not doing the 21 minus 2. We do the 2 times 7, 14, and then subtract it from 21 minus 14, which gives us 7. And lastly, 5 plus 3 with a negative 4. So we're not adding the 5 plus 3. We don't do that. That's running a stop sign. We don't do that. We have to multiply first and then add. So here we get 5 plus negative 12. And 5 plus minus is minus. So this is just 5 minus 12, which gives us negative 7. All right. Our last task here before we move on to cycle 3, day 3, is to circle the like terms found in each set of terms. Okay, so here you're playing a detective. You need accuracy and precision. All right, so who else might have the same term? So a term here would be like 4x squared y squared. That's a term. This one has xy. Okay, so that's different, right? This has 2 x's and 2 y's. This has 1 x and 1 y, so those don't go together. What about this one? This one has 1 x and 2 y's. Okay, none of these go together because that's 2 x's and 2 y's, 1 x, 1 y, 1 x, 2 y's. What about 2 y's and 2 x's? Yeah, this one has 2 y's and 2 x's. Those can go together. What about here? Anybody else can go together? Yeah, it looks like this one also has 2 x's and 2 y's as well. All right. Let's go here and check out some of these ones. Okay, so we have mn. Oh, that one doesn't have an mn, but it has a 3 m's and 1 n. This one also has 3 m's and 1 n, so those can go together. This has 1 m and 3 n's. Nobody else is like that, and nobody here in this line has 3 m's and 3 n's. All right, so those are the only two that can go together. What about here? 1p. Anyone else? That's a p and a q. There's 2 p's here. There's 1p. It has a -7, but that doesn't really matter. We're only trying to find the same terms. We're looking for the same terms. We're looking for the same variables. And then lastly, this one has an x. There's no variables, an x and a y. No variables can go together, and no variables can go together. So those are all what we call like terms. We're going to do the order up on Monday. So here we are on cycle 3, day 3. Just a quick integers review. So here we're looking at adding, subtracting integers. So for instance, if you have -1 and +1, we get 0. All right. So for instance, we have 5 plus -3. We talked about this already. You can take that plus minus and make it into a minus. So this is actually 5 minus 3. That gives us +2. And so on. Try those ones out. You can always use your Desmos calculator for these. I'm not going to go over too many because we have already done this. When multiplying or dividing integers, 2 positive make a positive, 2 negative make a positive, and a negative positive make a negative. If we have -3 times +5, this is negative, this is a positive, so we get a negative result, -15. Similar to division, if we have a negative and a negative, we're going to get a positive result, and 10 divided by 2 is 5. We're looking at b, and we just multiply right across. This is 5 times -1, we get -5. -5 times 4, that's -20. And -20 times -3, that's +60. Right, you can try the other ones. We've also done this already. It's BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. So try some of these out, and if you have any questions with them, let me know. Let's go right into some polynomial terminology again that we've looked at. So a variable is a symbol that represents a numerical value. So for instance, you can have the letter X, or your favorite letter, so like J for Johnston. Those are all considered variables. A coefficient is the number that is directly in front of a variable. So for instance, we can have like 3x, or let's keep with the J, 56J. Sure, 56 would be considered the coefficient. Same with 3 is the coefficient. An exponent is a value to which a number or variable has been raised to a power. So for instance, we can have like 3x squared. That would be our exponent. A term is a number or variable or the group of a number or one or more terms are variables. So here we talked about like 3x plus 2y. 3x would be the one term, 2y would be another term. You can have like 2y, x, z. This would still be considered a term. So it's like a grouping of variables, or you could have just one variable, that's fine. Like terms are terms that can be grouped together because they have the same variable and the same exponent. So for instance, like last lesson, we looked at a whole bunch of different like terms. So for instance, like 2m squared n squared, we have the same variables as let's say negative 7m squared n squared. But this is not. Something that is not a like term would be like 8m n squared. This only has one m. We're looking for 2. So those would be like terms. This one and this one would not be a like term. A constant is a term where the coefficient or number is not multiplied by a variable. So there's no variables here, but the variable might be in disguise. So for instance, you can have like the number 5, but we could have a variable, but the variable would be to the power of 0, meaning this would just be 5 times 1, which is 5. Lastly, a polynomial is an expression with one or more terms that are separated by a plus and a minus. So like 2x plus 3y plus 7z minus 5. Those are a whole bunch of terms, 1, 2, 3, 4 terms. If we had 3 terms, it's a trinomial, 2 terms, a binomial, or just 1 term would be a monomial.